We are going to talk about systems of linear equations, and we are going to do the graphing method. So system of linear equations, we are going to find the intersection of two lines. That's all it is. So by graphing, what we are going to do is we're going to solve these as y equals mx plus b, or use intercepts. And then we're going to graph these on a graph. So first, I'm going to use the intercepts for the first one, because if I use the cover-up method, and I'm going to go ahead and rewrite it down here. We have y-intercept equals 2 when you solve for y, and x-intercept equals 4. So if you plot 2, so on y-intercept is 2, so 1, 2, and x-intercept's at 4. If we take our straight edge ruler, because when you're graphing these, you have to be pretty precise. Let's see here. Let me find the slope. So 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. There we go. You can find the slope of your 2 points to find another point, because you kind of have to be pretty precise. And this is why I harp on drawing your line all the way through the graph instead of just drawing it here, or just like that, because your other line may intersect over here somewhere, may not. Here I'm going to go ahead and solve for y, so it'll be a lot less headache. So we can subtract 2 y over, and then we divide by 1, which will change our signs. Divide by -1. It will change our signs. So we are at -3, and then we go up 2 over 1, up 2 over 1, up 2 over 1, and we use our straight edge ruler. And see, this is why we want as many points as we can to get a straight line. And as you can see right here, this is where they intersect. So my answer is 2, 1. And if you plug that in, 4 minus 1 is 3. 2 plus 2 is 4. There we go. 2 plus 2 is 4. 4 minus 1 is 3. So this answer works for both of those equations. Let's do one more graphing. 2x minus 3y equals 13, and x plus 2y equals -4. So let's look at the first one. We can't do the cover-up method, so we need to solve for y to get into our mx plus b. Y equals mx plus b. Let's see here. -3y equals -2x plus 13. Divide by -3. So y equals 2/3 x minus 13/3. Oh my, 13/3? That's not very pleasant to graph. So anyway, I'm going to skip that one for right now. I'm going to go back to that one and try a different method to see if we can at least use the slope and graph it. So anyway, let's look at this one and graph it. So we can use the cover-up method. Y equals -2, y-intercept equals -2, and x-intercept equals -4. So let's go ahead and get those plotted. 1, 2, 3, 4. and then 1, 2, and then we have 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2. There we go. Get our line, and all I did was just use my slope between my two recent points, or my two current points, to find my third point. Now this one, well, if we cover that up, that's going to be our x running along our x-intercept. So if we do that, that would be 13 halves, which would be, what, 6.5? That's better than trying to do negative, what, 4 and 4 1/3. Okay. Another way you can do this is plug in, hey, let's plug in a 1 maybe. Okay, let's say, hey, what if x equals 1? Then we'll have y equals 2/3 minus 13 over 3. That will give us a negative 9/3, which would give us a negative 3. So there we go. So at 1, negative 1, 2, 3, we have our first point. So sometimes you might have to plug in a value, which is what I did here, to find a first point. Or if you want to use the x-intercept, that's going to give us 1, 2, 3, 4, 5, 6, and then 1/2. That's going to be right there in the middle. That's going to be kind of hard to make sure it works. And I hope I wrote this down right. Yes, I did. Okay. Now, I'm going to go ahead and since this is my solid awesome point, I am going to go up to 1, 2 over 3, 1, 2, 3, 1, 2, 1, 2, 3. 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. Okay, and see right here, it's not even like lining up. So that was not going to be a very good point. So 1, 2, 1, 2, 3. Maybe that was supposed to be a 12. So anyway, our intersection's right here, which is, it's not very easy to see. So graphing does not work all the way, or all the time. Okay, graphing does not work all the time, as you can see in this failed attempt. So let's do one more that will actually work. X plus y equals 13, it's dreaded 13, plus 3y equals negative 17. Okay, so let's go ahead and do this one. I know it will come out correctly. The other one, I think that 13 was supposed to be a 12. But it's nice to see that some methods just do not work with all of these. So graphing, so there's your proof, graphing is not the best method. So let's go ahead and solve for our y's. Y equals negative 4x plus 13. And here we still cannot cover up methods, so 3y equals 2x minus 17. All I did was add the 2x over, divide by 3, and there you go. We are coming up with fractions, but that's okay. This one should work. And fractions aren't that bad. We just have to look at what we have and figure out. We can always plug in 1 because we have a 3 in the denominator. So anyway, this one we have 13. I'm going to go, let's see here. How many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I really don't want to go ahead and go up here. So let's go 2, 4, 6, 8, 10, 12, 14. And again, don't really like doing this, but I will. And then we'll go 1, 2, 3, 4, and over 1. 1, 2, 3, 4 over 1. I really don't like doing that. Another way you can do this, let's see here, we can find, let's see here, we can go, since this is going downhill, let's say, well, x equals 4, well, what is y? So that's negative 16 plus 13. Y is going to be negative 3. So instead of doing half squares, because I don't like doing that, we are going to go for 1, 2, 3, 4, 1, oh, down, 1, 2, 3. And then from there, we can use our slope. We can go down 4, 1, 2, 3, 4 over 1. I'm going to run out of room, so I can go up 4, 1, 2, 3, 4, and left 1. There, that looks better. And then this way, we don't have to scale, use a different scale. And we're not attempting to find 13 way up there. And then this one, we can use the same method. Well, what if x equals 1? Well, we'll have 2 thirds minus 17 thirds. 2 minus 17 is negative 15, which would give us negative 5. So y equals negative 5. So 1, 2, 3, 4, 5. There we go. And then we can use the slope. 1, 2, 1, or 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. I kind of sound like I'm doing cha-cha here. Okay. So there is the intersection at 4, negative 3. And we're done. Graphing is not the best. Just remember that. We have 2 more ways to solve for these.